Hello everyone, welcome to this session of Lambda. Lambda is the serverless compute which is provided by AWS. This is our agenda. So, what is the definition of serverless? Does it mean we do not get any servers? We'll see some Lambda inline codes. We'll see the deployment packages of Lambda. We'll discuss various triggers of Lambda. First of all, what is serverless? Now, before going into serverless, what is the definition of a server? I think I have already discussed about servers in EC2. So you know what a server is. Server is a box which essentially gives you CPU and RAM power combined together. There are a lot of other things in the server also, like motherboard, bus, so on and so forth. But the basic purpose of having server is to get compute capacity so that you can run multiple things. For example, running your program or running your code, running a database engine, which by itself is a code in the background, running some application which also actually runs a code. As long as you have compute and RAM, as long as you have a box which can provide you compute capability, that is called a server. Storage has always been external, so you can attach storage to your server also. But the definition of server is providing CPU and RAM. Now, when you have to run a program in a server, what do? You go ahead and get the server, basically raise a server request, and the server is procured. The CPU and RAM are added as per the requirement, and then you install operating system, then you install certain packages and some runtime environment, and then you upload your code and execute it. For example, let's say you want to run a Python Flask web application and you want to run that program in a Linux environment. So what do? You have the server, you install the operating system, you install Python runtime, you install Flask runtime, you then write your code and upload it to the server and execute it. And of course, it has to be set behind a web server. So basically, in that case, your server gives you a lot of capability to execute your code, and your server is executing that code. So having said the definition of a server, what does serverless mean? Does it mean that you can execute your code without any server whatsoever? AWS introduced this concept of serverless, and it was a huge paradigm shift in the cloud computing arena. Of course, it confused a lot of people. Does it mean that you can run your code without a server? Does it mean that you get a compute platform without a server? The answer is, of course, no. I mean, serverless is defined in the context of the customer or the user. If we are an AWS user and we want to host a web server or a web page, for us that will be serverless. But AWS will still have to provision server to run our code. If I take the example of same Python code, what will happen is we'll not provision any server whatsoever. We'll not provision any runtime. We'll just upload the Python code and we'll tell AWS that we are uploading a Python code or a Java code or a Node.js code. What AWS will do is it will provide us the compute platform or the compute environment behind the scenes. We won't even see the compute platform. We won't even see that operating system or the Python or Flask or Java or JVM runtime. So it is serverless for us, and moreover, we pay only during the execution of the code. For example, if the entire day your Java application or Python application runs only for 4 hours, you'll have to pay only for 4 hours. And it takes out a lot of management and administration overhead of servers. If you think of EC2, you have to install the operating system, you have to install all the runtime environment, and then you upload your code. But in case of Lambda, you're just providing the code and Lambda service will execute your code and you'll have to pay only for the duration of your code execution. So basically, the serverless means it's compute power without having to provision or maintain or manage any server whatsoever. It is serverless in the context of customer, not for AWS. The reason it is serverless because you do not have to manage, maintain and provision any servers. For example, if you have a Python runtime or you want to execute a Flask program, you need the operating system, you need the Python runtime, you need the Flask runtime. And Lambda will provide you the compute environment. You just upload your code and the underlying facets of the server, for example, doing security patches, upgrading the operating system version, etc., will be taken care of by Lambda service itself. We do not have to do anything. So, serverless does not mean that there is no server. It is serverless in the context of the customer or the user or AWS users. Lambda is becoming very famous among developers because of this very reason that you do not have the overhead of server management. On top of it, Lambda gels really well with any of the CI/CD platform, continuous integration and continuous deployment. You can use Jenkins or any other CI/CD tool, any other automation tool. You can use AWS native DevOps toolchain to do continuous integration and continuous deployment using Lambda. Then comes the question of scalability. What about scaling? Do you have to take care of the scaling also? Now, before talking about scaling, let me tell you how Lambda works. Lambda works on events. So that event can be anything. It can be an event of, let's say, put method. If you're running a web service, you have got a put request or a get request. That can be an event. If you upload an object in S3 bucket, that can also be an event. You can integrate Lambda with CloudWatch events also. If you insert an item in a DynamoDB table, that can also considered to be an event. So you get an event, and based on the event, the Lambda function is triggered. Now the scope of event is really huge. You can actually host 3-tier application using Lambda also. You can host your backend application in the 3-tier architecture using Lambda. As I said, if you get a get or post request or any other HTTP methods, you can consider that as an event, and you can trigger Lambda function based on that event. It's a single event. So if you get a single get request from a user, that will be a single event. If you upload a single object in S3, that will also be a single event. What if you upload multiple objects in S3? Or what if you have millions of users doing get requests or thousands of users doing post requests? How do the scaling happens? Whatever code you upload in Lambda function, that code is executed for a single event. So if you have a single get request, your Lambda code will be executed only once. If you have millions of users triggering millions of events, then the same Lambda function will get executed millions of times. If you upload, let's say, thousands of S3 objects at the same time, then your Lambda function will get executed thousands of times. The same code, but multiple number of times. So that's what event based is. And now if you see, the scalability is taken care of by Lambda service automatically. You do not have to do anything whatsoever. As it is event based, Lambda will be executed based on the event, and if your number of events increase, so will the number of execution of Lambda functions. Same is the case with high availability also. When you execute your code, when you upload your code, you don't have to take care of the AZ or the data center. You just upload your code. The availability will be taken care of by AWS or Lambda service itself. It will give you multi-AZ feature by default without you having to do anything whatsoever. There's no multi-region feature as of now. That might come later on, but yes, you can get high availability by default. What can be the different triggers of Lambda? You can have API gateway. This is one of the very famous use cases of AWS Lambda. API gateway actually is used to host your backend web services or backend APIs, and the front end can be hosted anywhere. If it is a static website, you can host it in S3. If it is a dynamic website, you can host it in either Lambda or EC2 or Elastic Beanstalk, and then direct the user requests via API gateway. Now, API gateway is a gateway to host your backend web services, and the backend web services can be provided by Lambda itself. And then S3 events, DynamoDB streams. Whenever you upload an object in S3, that can consider to be an S3 event, and you can trigger a Lambda function based on that. For example, suppose you upload an image in your S3 bucket. So when you upload an image, what you want to do is you want to create a thumbnail automatically. So suppose you have an application, something like Instagram, which can be used to take a photo and upload the photo somewhere. And whenever you upload the photo, you want to create a thumbnail out of it. So if you're using S3 behind the scenes to store your photos, and the moment your application uploads a photo in S3, that will be an event, and that should trigger a Lambda function, which will create a thumbnail in the background and upload it back to the same S3 bucket or in a different S3 bucket. So that can also be a trigger. Then DynamoDB. Suppose you are inserting or updating items in DynamoDB using put item, update item, APIs, etc. So based on that, you want to take certain actions. You can trigger Lambda function to take those actions as well. Lambda can be triggered with Kinesis, it can be triggered with SNS, SQS, CloudWatch logs and CloudWatch events, which I have already shown you on a very high level. You can have Lambda functions integrated with CloudWatch events also. So that's all about Lambda in theory. Let's go ahead and do some hands-on using Lambda functions.